A perfect ring of fire spins through the void, a cosmic accident of unbelievable scale. This is the Cartwheel Galaxy, and its bizarre structure defies everything we thought we knew about how galaxies live and die. By the end of this journey, you will understand 30 of its strangest secrets, from ghostly inner rings to stars being born at a frantic, unsustainable pace. How did a single collision rewrite the rules of physics to create this celestial bullseye? And what does its missing central core tell us about the violence of its past? What does it feel like to witness a universe that constantly remakes its own rules? This perfect bullseye is a cosmic lie, a beautiful illusion of order born from pure chaos. That massive ring structure, spanning 150,000 light-years, is not a solid band of stars at all. It is a wave, a propagating shockwave of creation racing outward through the galaxy. Imagine a single stone dropped into a still pond, sending ripples expanding across the surface. Now, replace the stone with an entire galaxy and the pond with the cartwheel. Millions of years ago, a smaller intruder galaxy pierced straight through the heart of this system. It did not collide in a messy crash, but passed clean through the center like a bullet. This violent trespass sent a colossal ripple of compressed gas and dust rushing outward. This is what astronomers call a density wave, a cosmic tsunami that forever changed this galaxy's destiny. As the wave expands, it piles up the raw material for making stars, squeezing vast clouds of hydrogen until they collapse under their own weight. The brilliant glow of the ring is the fire of countless stellar nurseries, all igniting at once in the wake of this wave. The sheer symmetry and scale of this process are unlike anything else we have ever found. It makes the Cartwheel Galaxy a living laboratory, a place where we can watch the chain reaction of star formation unfold on a truly epic scale. This ring is not a static picture, it is a movie, a continuous explosion of new life set in motion by a single, catastrophic event. But this cosmic tsunami left behind more than just one wave. Nestled within that brilliant outer ring of fire is a second, far more subtle structure. A faint, ghostly inner ring glows with the cooler, redder light of ancient stars. It is a pale echo of the galaxy's former self, a relic from a time before the Great Collision. This inner ring feels almost detached from the main event, a quiet spectator to the frantic star birth happening further out. Its very existence is a profound puzzle. How could such a delicate structure survive the galactic equivalent of a bullet shot straight through the heart? The violent shockwave that created the outer ring should have torn this inner remnant to shreds, scattering its stars into the void. The fact that it remains, albeit faintly, tells us that the energy of the impact was transferred in a very specific, almost surgical way. It suggests the smaller intruder galaxy did not just plow through randomly. It transferred a tremendous amount of angular momentum, like a perfectly struck billiard ball, setting the entire galaxy spinning in a new way and triggering these two distinct waves of creation. The older, redder stars of the inner ring are the surviving population from the original galaxy, the ancient core that endured the cataclysm. They are the living memory of what the Cartwheel Galaxy used to be, a silent archive of its pre-collision history. This faint inner loop is a crucial clue, a second chapter in the story written in starlight, forcing us to ask what other secrets are hidden within its pale glow. These ancient bridges of dust and gas reach out like ghostly fingers from the galactic heart. They are the spokes of the cartwheel, faint yet persistent structures that defy the chaos which created the ring itself. While the outer ring blazes with the fire of new stars and the inner ring glows with ancient light, these radial filaments tell a different story entirely. They are not a product of the collision, but rather a survivor of it. Before the intruder galaxy pierced its center, the cartwheel was likely a majestic spiral, much like our own Milky Way, with graceful arms winding around its core. The cataclysmic impact did not vaporize these arms. Instead, it stretched them, pulling them taut across the vast emptiness like cosmic taffy. What we see now as faint spokes are the skeletal remains of those original spiral arms, their stars largely scattered, but their lanes of darker dust and gas stubbornly holding together. They are the galaxy's original blueprint, a memory written in shadows that the Great Wave could not completely erase. Their very persistence is a profound clue. It tells us that the original gravitational and magnetic fields of the galaxy were incredibly strong, woven together in a way that could endure even this level of violence. These fields acted like a cosmic skeleton, providing a framework that held the dust and gas in these spindly shapes despite the galaxy being turned inside out. And they are not merely relics. These spokes are active conduits functioning like celestial aqueducts. They funnel cold gas and the raw building blocks of solar systems from the quieter inner regions out toward the frantic star-forming ring. This continuous flow of material is what fuels the ongoing fire of the outer ring, suggesting that the galaxy's rebirth is a process still very much in motion. How can something so delicate continue to feed something so immense? The survival of these fragile bridges proves that even in the wake of total destruction, the ghosts of a galaxy's past can still shape its turbulent future. This violent reshaping did not end at the brilliant ring. Beyond the main wheel, in the deep black, lies a ghost. A vast, faint, and startlingly lopsided halo of ancient stars envelops the entire system, a cosmic shroud torn from the galaxy's body during the collision. This outer halo is not the smooth, symmetrical glow you might expect. Instead, it is lumpy and uneven, marked by faint clumps and long, streaming rivers of stars. These are the scars of tidal forces, the same gravitational pull that gives our ocean its tides, but operating on an unimaginable scale. As the intruder galaxy passed through, its gravity did not just push and pull, it violently stretched the outer regions of the cartwheel, ripping billions of stars from their original orbits and flinging them into the void. The very shape of this lopsided halo is a fossil record, a three-dimensional map of that ancient catastrophe. Its asymmetry is the crucial clue. A direct head-on collision would have likely created a more rounded, evenly distributed halo. The fact that it is so clearly lopsided tells us the impact was a glancing blow. The smaller galaxy did not hit the center dead-on, but struck at an angle, a cosmic sideswipe that imparted a tremendous spin and tore material away more violently from one side than the other. By mapping the distribution of these exiled stars, astronomers can essentially rewind the event. They can calculate the angle of approach and even estimate the incredible speed at which the two galaxies passed each other. This faint, mangled halo is not just debris, it is the final and most distant echo of the impact, a silent witness to the precise mechanics of a collision that happened millions of years ago. Scattered across that brilliant ring of fire are points of light that burn with a different kind of energy. These are not the gentle glow of newborn stars, but the searing, concentrated blast of X-rays. Astronomers call them ultra-luminous X-ray sources, or ULXS for short, and they are cosmic powerhouses that should not exist. A single one of these objects can outshine a million suns, all in the high-energy X-ray part of the spectrum. Their sheer brightness breaks one of the fundamental rules of astrophysics, a law known as the Eddington limit. Think of a campfire. If you build it too big, the intense heat and light it produces will actually push the fuel away, preventing the fire from growing any larger. The same principle applies to cosmic objects like black holes. As they pull in or accrete surrounding gas, that gas heats up and glows brilliantly. There is a theoretical maximum to how bright this process can get before the radiation pressure blows the incoming fuel stream apart. Yet these ULXS in the Cartwheel Galaxy are shining hundreds, sometimes thousands of times brighter than that calculated limit. They are cosmic bonfires burning out of control, and their existence forces us to rewrite the textbooks. What kind of engine could possibly produce so much power without tearing itself to pieces? The leading theory points to a new class of black hole, one that has long been a missing link in our cosmic family tree. These could be intermediate mass black holes with masses thousands of times greater than our Sun. They would be the perfect power source, massive enough to potentially accrete matter at a super Eddington rate, creating a thick, dense disk of material that funnels the incredible energy output like a cosmic blowtorch. Another possibility is that they are more familiar stellar mass black holes, but ones that are feeding in a unique way. Instead of a smooth, flat disk of incoming gas, they might be surrounded by a puffy, superheated cloud that traps its own radiation, allowing the black hole to gorge itself far beyond its normal limits. The Cartwheel Galaxy is a hotspot for these bizarre objects precisely because of its violent history. The same density wave that triggered the firestorm of star formation also created the perfect conditions for ULXS. It forged countless massive, short-lived stars. These stars burn bright and die young, collapsing into black holes and neutron stars and flooding the region with abundant fuel in the form of gas and dust. The ULXS are the ultimate offspring of the Great Collision, the brilliant and violent children of the ring itself. They are not merely curiosities. They are direct probes into the most extreme physical processes in the universe, challenging our understanding of how matter behaves under the most ferocious gravitational stress imaginable. The brilliant chaos of the ring points back to a central mystery, a profound emptiness where there should be a heart. Most large galaxies, including our own Milky Way, possess a dense, brilliant core called a central bulge, a tightly packed sphere of ancient stars that acts as the galaxy's anchor. The Cartwheel Galaxy, for all its spectacle, seems to have lost its own. Its center is surprisingly faint and quiet, a dim nucleus overshadowed by the blazing wheel around it. This missing bulge is more than just an oddity. It is a direct challenge to our understanding of how galaxies are built and how they survive colossal violence. So, what happened to the Cartwheel's core? The leading theory is as dramatic as the ring itself. When the smaller galaxy pierced through the center millions of years ago, its gravitational force may have acted like a cosmic wrecking ball. It could have violently disrupted the orderly orbits of the billions of stars that made up the original bulge, scattering them outward into the growing halo or flinging them into the newly forming rings. The central gravitational anchor was in effect torn out. Another possibility is that the collision did not destroy the bulge, but simply put its star formation to sleep. The immense density wave that rushed outward to create the ring would have siphoned away the cold gas and dust from the center, the very fuel needed to form new stars. This left the galactic core starved and quiescent, its existing ancient stars aging without any new, bright offspring to light them up. Could the bulge simply be hidden? Perhaps it is still there, but its light is drowned out by the incredible glare from the trillions of new stars in the ring, or obscured by the thick lanes of dust in the spokes. Yet, detailed observations suggest the core is genuinely deficient. The collision did not just rearrange the galaxy's appearance, it performed galactic surgery, fundamentally altering its core architecture in a way that models of galaxy evolution struggle to explain. The quiet center of the Cartwheel Galaxy forces us to ask a deeper question. Can a galaxy survive the loss of its own heart? And if so, what new kind of cosmic structure emerges from the emptiness left behind? These high-speed gas clouds are the galaxy's own blood splattered across the cosmos. While the rings glow and the spokes endure, these vast clouds of hydrogen are the most direct evidence of the impact's raw violence. They are not calmly drifting through space, they are being flung outward at millions of miles per hour, some moving so fast they are achieving escape velocity, breaking free from the cartwheel's gravitational pull entirely. Imagine a vast ocean struck by a meteor. The initial splash would send droplets flying in all directions, some of them moving fast enough to never fall back into the sea. This is the galactic equivalent. When the intruder galaxy pierced the heart of the Cartwheel, it did not just create a gentle wave, its shock heated enormous reservoirs of hydrogen gas to incredible temperatures. This superheated plasma, no longer bound by cool, dense clouds, was given a tremendous kick, a blast of kinetic energy that sent it racing outward. Each of these fleeing clouds is a cosmic tracer bullet, its trajectory a frozen moment from that ancient collision. By meticulously mapping their paths and speeds, astronomers can perform a kind of forensic astronomy. They can trace the streams of gas backward, like following the spray pattern from a bullet wound, to pinpoint the exact angle and direction of the intruder's catastrophic path. This is how we know it was a glancing blow and not a direct hit. The lopsided distribution of these hypervelocity clouds tells the story of an impactor that came in from one side and exited from another, transferring immense energy asymmetrically. But what becomes of this exiled material? These clouds are destined for a lonely eternity in the intergalactic void. They will drift through the profound cold and emptiness between galaxies, vast islands of raw hydrogen that may never form stars. Over billions of years, they might slowly, gradually be recaptured by the Cartwheel's future gravitational pull, or perhaps they will be snatched up by another passing galaxy, becoming a ghostly contribution to a future cosmic structure. For now, they are the final, fading breath of the collision, a permanent signature of the day the Cartwheel Galaxy was remade by force. This cosmic violence was not the first time the Cartwheel Galaxy reshaped itself by force. Before the great collision that forged its iconic ring, it was already a predator. The Cartwheel is not a solitary wanderer. It is the dominant member of a small group of galaxies, and over billions of years, it has been engaged in a slow gravitational feast. This process is known as galactic cannibalism, where a larger galaxy tears apart and absorbs smaller dwarf galaxies that venture too close. The evidence for this ancient diet is written in the faint, messy halo that surrounds the neat ring structure. If you look closely past the brilliant wheel, you can see faint rivers of stars and vast clouds of stellar debris. These are tidal streams, the shredded remains of the Cartwheel's past meals, still orbiting in wide, looping paths. They are the cosmic equivalent of bones scattered around a den, telling the story of what was consumed. Each of these accretion events added to the Cartwheel's mass and complexity, building up its reserves of gas and stars long before the intruder galaxy ever arrived. This history of mergers helps explain its peculiar morphology. The galaxy that was struck millions of years ago was not a pristine spiral. It was a hybrid, a patchwork entity whose structure had already been altered by these earlier, quieter collisions. The consumption of dwarf galaxies would have puffed up its outer regions, perhaps contributing to the lopsided halo we see today and providing extra fuel for the incredible star formation that followed the main impact. This layered history forces us to see the Cartwheel not as a single-event galaxy, but as a chronicle of violence, a system that has been growing and changing through a series of dramatic encounters across nearly the entire age of the universe. How many other galactic tales are hidden within that faint, messy glow? Even the invisible architecture of this galaxy has been warped into something new. A powerful and strangely ordered magnetic field weaves through the chaos of the Cartwheel, a silent force holding the brilliant ring together. This magnetic presence is deeply puzzling. A collision of this magnitude should have scrambled the galaxy's magnetic field into a tangled, chaotic mess, like stirring a bowl of iron filings into disarray. Instead, observations reveal a field that is not only intact but amplified, particularly along the outer ring where star formation is most intense. This magnetic scaffold acts like an invisible cage, containing the vast clouds of gas and dust within the ring and preventing them from simply flying apart into the void. It also governs the very birth of stars, as a giant cloud of gas begins to collapse under its own gravity to form new suns. the magnetic field within it provides a crucial counterforce, a form of cosmic resistance that slows the collapse. This regulation is vital. Without it, star formation would be even more frantic and chaotic, a brief, explosive burst that would quickly exhaust all the available fuel. The ordered magnetic field forces the gas to collapse in a more controlled, sustainable manner, effectively pacing the galaxy's fiery rebirth. So how did this strong, organized field survive the galactic bullet or even grow stronger because of it? The leading theory points to a process called a dynamo. The immense turbulence within the ring, the churning motion of superheated gas, and the powerful shockwaves from supernova could be acting like a colossal generator. This motion, converting kinetic energy into magnetic energy, continuously amplifies and organizes the magnetic field, weaving order from the very heart of the disorder. The beautiful ring of fire we see is not just a product of gravity and shockwaves. It is a structure sculpted and sustained by this invisible magnetic hand. What other cosmic processes are being guided by forces we cannot directly see? These brilliant knots of light are entire cities of stars. Each glowing point you see in that fiery outer ring is not a single sun, but a superstar cluster, a stellar metropolis so dense it crams the equivalent of 1,000,000 suns into a space just a few light years across. To grasp that scale, imagine taking every star in a vast region of our own galaxy and compressing them all into the narrow gap between our solar system and its nearest neighbor. The result is a place of unimaginable stellar density, a cosmic forge operating at its absolute limit. The formation of these clusters is a direct and violent consequence of the ring wave itself. As that colossal density wave races outward, it does not just gently squeeze the gas, it slams into it with the force of a galactic hammer blow. This creates pockets of gas so incredibly dense and under such immense pressure that the entire cloud collapses not into one star or 100, but into 1,000,000 stars all at once in a single, frenzied burst of creation. These are not the quiet, orderly nurseries we sometimes see in calmer galaxies. This is star formation as a catastrophic event, a firestorm of birth that forges entire generations of stars in a geological instant. What is truly staggering is that these newborn superclusters are the direct counterparts to the most ancient objects in our own night sky, the globular clusters that orbit the Milky Way like distant fossilized bees. Our galaxy's globular clusters are ancient relics over 12 billion years old, and their formation process has long been a mystery. They were thought to be a feature of the early universe, a type of object that simply could not form in the modern, more evolved cosmos. The Cartwheel Galaxy is proving that wrong. Here, in the present day, we are witnessing the birth of what will one day become those very same ancient globular clusters. We are catching them in their cosmic infancy, seeing firsthand the violent conditions required to build such immense and durable structures. These clusters are the ultimate survivors. The same intense gravity that binds them together at birth will allow them to endure for billions of years, sailing through the galaxy long after the brilliant ring that gave them life has finally faded away. They are the permanent legacy of the Great Collision, celestial diamonds forged in a temporary fire. Hidden within the brilliant stellar cities of the ring are ticking time bombs. These are not the familiar supernova that mark the death of a single star, but something far more rare and cataclysmic, the potential birthplaces of long-duration gamma-ray bursts. These events are the most powerful explosions in the universe since the Big Bang itself, and the Cartwheel Galaxy's frantic ring may be the perfect factory for creating them. To produce a gamma-ray burst, a star must be exceptionally massive, spin at a tremendous speed, and possess a very specific chemical makeup, being low in elements heavier than hydrogen and helium, what astronomers call low metallicity. The superstar clusters in the Cartwheel's ring check every single box. The violent collapse of those immense gas clouds naturally forges colossal stars, and the chaotic environment can easily set them spinning like cosmic tops. Furthermore, the gas in the ring, though enriched by the ongoing star formation, is still considered relatively pristine compared to the material in a galaxy like our own Milky Way, providing that crucial low metallicity ingredient. While we have been fortunate that no such burst has yet been detected from the Cartwheel, the probability is unnervingly high. At any moment within one of those brilliant knots of light, a monster star could exhaust its fuel and collapse. Its core would not simply form a neutron star or a black hole in a relatively orderly fashion. Instead, the rapid rotation would focus the star's dying energy into two narrow, opposing beams of pure gamma radiation, firing from its poles like a cosmic laser. If one of these beams were by chance pointed toward our solar system, what would we witness? For up to a minute, the gamma-ray burst would outshine every other source of gamma rays in the entire sky, including the combined light of every star in every galaxy. It would deliver, in that brief flash, more energy than our Sun will produce over its entire 10 billion-year lifetime. For astronomy, catching such an event in a galaxy we are already studying so intensely would be a transformative moment. It would confirm our theories about their origins and allow us to dissect the final moments of a star unlike any other. The Cartwheel's ring is not just a place of birth, it is a gallery of potential destruction, holding within its fire the seeds of the universe's most spectacular finales. The brilliant chaos of stars and gas is only half the story. The true architecture of the Cartwheel Galaxy is built from something invisible, a cosmic skeleton of dark matter that was itself reshaped by the Great Collision. We cannot see this dark matter, for it does not emit, absorb, or reflect any light. Its presence is revealed only through its immense gravitational pull, a force so strong it warps the very fabric of space-time around the galaxy. This phenomenon, called gravitational lensing, allows astronomers to map the unseen by watching how the Cartwheel's gravity bends the light from even more distant galaxies behind it. These background galaxies appear as faint, stretched arcs, their distorted shapes tracing out the contours of the Cartwheel's total mass, both visible and dark. What these lensing studies reveal is deeply strange. The distribution of this dark matter halo does not neatly align with the beautiful ring of stars we see. It seems to be offset or distorted, as if the collision knocked the galaxy's invisible skeleton out of alignment with its visible body. Think of a marionette. The puppet you see dancing on the stage is the glowing ring of stars, but its movements are controlled by the puppeteer's hands, the unseen dark matter. In the Cartwheel, it appears the collision violently jerked the puppeteer's arms, leaving the puppet moving in a way that no longer perfectly matches the hands guiding it. This mismatch occurs because dark matter interacts only through gravity. During the impact, the visible stars and gas collided. They felt friction. They compressed and heated, creating the shockwave and the ring. But the dark matter particles, ghostly and non-interacting, simply passed through the intruder galaxy and each other. They responded only to the changing gravitational landscape, sloshing and oscillating within the halo in a way the normal matter could not. This provides a once-in-a-lifetime experiment. By studying this offset, we can probe the fundamental nature of dark matter itself. Is it cold and slow-moving, or could it have some tiny, subtle interactions we have not yet detected? The Cartwheel's distorted halo is a cosmic clue, a fingerprint left behind by the universe's most mysterious substance during a moment of extreme violence. What other secrets about the invisible framework of the cosmos are hidden within this gravitational ghost? This chemical map of the ring reveals a story of cosmic chaos written in the language of elements. The brilliant band of light is not a uniform structure but a patchwork of different chemical histories. Astronomers can measure the metallicity of the gas, which is a term for the concentration of all elements heavier than hydrogen and helium. These heavier elements, like carbon, oxygen, and iron, are forged only in the hearts of stars and are scattered into space when those stars die in supernova explosions. In a calm, settled galaxy, these elements would have billions of years to mix evenly like a well-stirred batter. The Cartwheel's ring shows no such uniformity. Instead, we find sharp gradients and strange pockets. Some regions of the ring are surprisingly pristine, with a chemical signature almost as pure as the gas that filled the early universe. These are likely vast reservoirs of cold gas that were swept up from the galaxy's untouched outer regions by the expanding density wave, pulled into the ring before they could be contaminated by the products of stellar death. Right next to these primordial pockets are zones of extreme enrichment where the concentration of heavy elements is explosively high. These are the pollution zones, areas dominated by the recent ejecta of supernova. Imagine a forest fire sweeping across a landscape, and in its wake you can still see the distinct, separate piles of fresh timber and the scattered ashes of what has already burned. That is the chemical state of the Cartwheel's ring. The collision did not just trigger star formation, it triggered it in such a violent, stuttering wave that the galaxy has not had time to clean up after itself. The supernova blast waves from the first generation of stars to form in the ring have carved out bubbles and flooded their immediate surroundings with freshly forged metals. But this enriched material has not yet blended smoothly with the incoming pristine gas. By reading this chemical map, astronomers are effectively reading a timeline. The most enriched areas mark the spots where star formation began earliest and most intensely, while the pristine zones are the newest arrivals to the chaotic party. This incomplete mixing gives the galaxy a strange, unfinished quality, a cosmic work in progress where the raw ingredients of creation remain starkly separate from its fiery waste products. What does this tell us about the ultimate fate of this celestial ring? The brilliant ring of the Cartwheel Galaxy is not just a place of creation, it is also a place of immense destruction. Deep within that band of fiery light, radio telescopes have mapped a startling void, a great hole in the sea of neutral hydrogen gas that should fill the region. This is not a small gap, but a colossal bubble of emptiness, a cosmic cavity on a scale that defies easy comprehension. This missing gas is the primary fuel for star formation, and its absence in such a large volume is a profound clue to the violence unfolding within the ring. How does a galaxy carve out a hole in its own lifeblood? The leading explanation is as violent as it is beautiful. This void is likely a superbubble, a single, gargantuan structure blown clear by the combined fury of hundreds of massive stars. Each of these giant stars, many dozens of times larger than our own sun, burns fiercely and dies young. During their short lives, they blast space with powerful stellar winds, a continuous hurricane of charged particles. When their fuel is exhausted, they do not fade quietly. They explode as supernova, unleashing shockwaves of unimaginable force. When hundreds of these titans are born together in one of the galaxy's superstar clusters, their collective winds and successive explosions can combine. They act in concert, pushing the surrounding gas outward and merging their individual bubbles into one single, monstrous cavity. Think of it like a crowd of people all blowing soap bubbles at once in the same spot, their smaller bubbles merging into one enormous, fragile sphere. This superbubble expands, sweeping up the hydrogen gas into a dense shell on its edges and leaving a vast, empty region in its wake. The other possibility is even more extreme. Perhaps this hole is not a bubble blown clear, but a tomb. It could be a region where the gas was not pushed away, but completely used up. The density wave that triggered star formation here may have been so efficient, so overwhelming, that it converted every last atom of available hydrogen into stars in one frantic, unsustainable burst. The void is what remains after the feast, a galactic dead zone where the fuel tank has been hit zero. This would be star formation as a self-destructive fire, a blaze so intense it consumes its own foundation. The existence of this hole forces a difficult question. Is the Cartwheel's magnificent ring ultimately a temporary structure, one that will eventually tear itself apart from the inside out, leaving behind a galaxy pockmarked with empty cavities and shells of used-up gas. The entire outer ring of the Cartwheel Galaxy is on the move, racing outward at 100 kilometers every single second. This is not a galaxy frozen in a single moment of beauty, but a structure actively exploding into the void, its leading edge pushing ever forward. That incredible speed, captured by precise astrometric measurements, is the definitive proof of the density wave theory in action. The ring is not a solid object but a traveling front of compressed gas, a propagating wall of pressure that ignites stars in its wake. Think of a snowplow barreling down a wide street, its blade piling up a massive, continuous ridge of snow ahead of it. The plow itself is the invisible density wave, and the growing pile of snow is the brilliant ring of newborn stars. We are witnessing a single, ongoing event, a wave that has been traveling for millions of years. This constant, measurable expansion allows us to perform a stunning feat of cosmic forensics. By knowing its current speed and its distance from the galactic center, astronomers can simply rewind the motion. They can calculate how long it took for the wave to travel from the core to its present position. The math points to a cataclysm that occurred approximately 200 million years ago. This is the birthday of the ring itself. 200 million years ago, a smaller galaxy sliced through the Cartwheel's heart, and the echo of that impact is still visibly racing across the sky. This precise dating transforms the galaxy from a static picture into a movie with a known timeline. It tells us that the brilliant spectacle we see today is a relatively recent chapter in the universe's long history, a fleeting era of violent rebirth set in motion when dinosaurs still roamed our own planet. What other cosmic events are unfolding around us right now? They're slow-motion stories waiting for us to learn how to read their speed, but those brilliant knots of light could be much more than just cities of stars. Some of the largest and brightest clumps in the ring are candidates for a phenomenon that turns the very idea of a galaxy on its head. They may be infant tidal dwarf galaxies, entire stellar systems being born from the wreckage of the Great Collision. Unlike normal dwarf galaxies, which are ancient relics from the dawn of time, these objects are being forged in the present day from the tidal debris of two larger galaxies. They are not collapsing from primordial gas, but condensing from the giant, shredded clouds of gas and dust that were violently pulled from the Cartwheel and its intruder. The key difference lies in gravity. A simple star cluster is held together by the mutual gravity of its stars, but it orbits within the larger gravitational well of its parent galaxy. A true tidal dwarf galaxy becomes self-gravitating. It develops its own distinct gravitational core, typically from a large amount of dark matter-free gas that condenses and begins to pull itself together. This creates a cohesive entity that can hold onto its own gas and dust, potentially forming its own generations of stars independently from the Cartwheel. The evidence for these infant galaxies is compelling, though not yet conclusive. The suspected knots are unusually massive and bright, and spectroscopic studies suggest they contain vast reservoirs of cold gas, the exact raw material needed to sustain an independent stellar system. They are not just passive clusters, but active, bustling regions with all the ingredients for a long-term future. If confirmed, their implications are staggering. It means the collision did not just rearrange a single galaxy. It triggered a process of galactic reproduction. From the destruction of one large galaxy, multiple smaller, new galaxies could be born. These tidal dwarf galaxies would be the ultimate survivors. Long after the Cartwheel's magnificent ring has dissipated, its stars scattered and its fuel exhausted, these infant galaxies could continue their journey through the cosmos. They would drift away from their birthplace, becoming permanent, independent satellites in the galactic group, each one a living fossil that tells the story of the violent day its parent was shattered and reborn. Deep within the galaxy's quiet center, a sleeping giant is stirring. The faint light at the very heart of the Cartwheel does not come from a placid cluster of old stars alone. It is the sign of a supermassive black hole, an object millions of times heavier than our Sun, that is slowly, erratically feeding. This is a low-luminosity active galactic nucleus, or a GN, a shadow of the cosmic powerhouse it could have been. In other galaxies, such a black hole would be a brilliant quasar, outshining every star in the system as it devours vast quantities of gas. But here, the feast is a chaotic and meager one. The black hole's brightness flickers in a strange, unpredictable pattern, flaring up for a short time before dimming again. This sporadic heartbeat tells a story of starvation amidst plenty. The great collision that ripped through the Cartwheel sent a tsunami of gas rushing outward to form the ring, effectively robbing the central black hole of the steady fuel supply it needed to awaken fully. Instead of a smooth, continuous river of material flowing inward, the black hole receives only scattered dribbles and clumps of gas, perhaps funneled along the remaining magnetic fields or tossed inward by the gravitational turmoil. One moment, a small cloud of matter crosses the event horizon, and a brief flare of X-rays signals a momentary bite. Then, for a long while, there is nothing. This erratic activity provides a rare cosmic experiment. We are witnessing how a galactic collision can both trigger and then stifle a black hole's awakening. The same violence that could have turned the core into a brilliant beacon ultimately left it gasping, a muted engine in a galaxy of fire. What does this stuttering heartbeat reveal about the final fate of this celestial giant, forever trapped between slumber and eruption? The Cartwheel Galaxy glows with a hidden fire. Its true brilliance is not in the dazzling blue light of its ring, but in a spectrum our eyes cannot see. This celestial wheel is an extreme infrared emitter, radiating more energy as invisible heat than in all the visible wavelengths combined. The reason for this lies in the cosmic dust, an immense amount of fine, sooty particles forged in the very starburst that makes the ring so spectacular. When a massive, short-lived star explodes as a supernova, it does not just scatter heavy elements, it also seeds space with countless trillions of dust grains. The Cartwheel's ring is a factory for this dust, producing it on an industrial scale. The ultraviolet and visible light from all those newborn stars, the very light that paints the ring in brilliant blue, does not simply escape into space. It slams into this vast, opaque shroud of dust. The dust absorbs that furious energy, heating up until it glows, re-radiating all that captured starlight as a warm, pervasive infrared glow. This transformation of light into heat makes the Cartwheel a prime example of a luminous infrared galaxy, or LIRG. Its entire energy budget is dominated by this process. By measuring the precise balance between the visible light that escapes and the infrared heat that is emitted, astronomers can perform a kind of cosmic accounting. They can calculate exactly how much of the collision's raw kinetic energy was converted first into starlight, and then finally into this pervasive thermal blanket. It is a complete picture of the energy life cycle within a galactic catastrophe. This hidden infrared luminosity is the galaxy's true signature, the final and most honest testament to the sheer scale of the star-forming frenzy within. What other cosmic fires are burning just beyond the limits of our sight, their stories told only in the silent language of heat? Even the light escaping the Cartwheel Galaxy carries a hidden signature, a subtle alignment that reveals the invisible forces at work. When astronomers analyze the brilliant glow of the ring, they find that its light is highly polarized. This means the light waves are not vibrating in all directions randomly, but instead show a strong preference for a single plane, like sunlight glinting off the surface of a lake. This pervasive polarization is not a random effect. It is the direct result of that brilliant starlight scattering off of trillions of tiny, needle-like dust grains that fill the ring. For the light to become polarized in such a uniform way, those countless dust grains cannot be tumbling chaotically. They must be aligned, all pointing in roughly the same direction across vast stretches of space. The only force capable of performing this cosmic tidying act on such an immense scale is the galaxy's magnetic field. Think of the dust grains as countless tiny compass needles. The magnetic field lines that weave through the turbulent gas act like a master current, forcing these needles to line up with the field's direction. When light from the new stars zips through this region, it bounces off these aligned grains and becomes polarized, its vibration direction stamped with the orientation of the magnetic field at that exact location. This phenomenon transforms the entire galactic ring into a giant natural polarizing filter. By meticulously mapping the direction and degree of polarization across the ring, astronomers can do something extraordinary. They can trace the geometry of the magnetic field itself, drawing the lines of force that are entirely invisible to any other type of telescope. This polarized light paints a picture of a magnetic field that is surprisingly ordered, running along the length of the brilliant ring, acting like a cosmic corset that holds the entire structure together against the forces trying to blow it apart. It reveals a magnetic personality for the galaxy, one of powerful organization born from the heart of chaos, showing us that even in the aftermath of destruction, an invisible hand is still guiding the light. The architect of this cosmic wheel is still on the run. Far from the brilliant ring it helped create, the smaller intruder galaxy drifts through the void, a ghost from the Cartwheel's violent past. Astronomers have identified it as a distorted spiral known simply as G3, and its current form is a testament to the mutual destruction of that ancient encounter. G3 did not escape unscathed. Its own spiral arms are now mangled and stretched, pulled out of shape by the same gravitational forces that tore the Cartwheel apart. Long streams of stars and gas, its own tidal debris, trail behind it like a cosmic wake, marking its path of retreat. This galaxy is no longer a pristine spiral. It has been remade into a peculiar object, a permanent casualty of the collision it initiated. By meticulously tracing its current trajectory and velocity away from the Cartwheel, scientists can rewind its motion through space. The path leads back with stunning precision, straight through the heart of the Cartwheel Galaxy approximately 200 million years ago. This is the forensic evidence that confirms G3 as the cosmic bullet, the perpetrator of the crime. Its flight path is the final, irrefutable piece of the puzzle. Yet this galactic story may not be over. The gravitational bond between the two galaxies, though stretched across a vast distance, has not been broken. G3 is not moving fast enough to achieve true escape velocity. Its current path suggests it is now at the most distant point of a colossal billion-year orbit. The pull of the Cartwheel's immense dark matter halo is like a cosmic tether, and it will eventually begin to slow G3's flight, then pull it back inward. This opens the door to a staggering possibility. In the far distant future, this intruder galaxy could swing back for another encounter. It would not be a clean, piercing shot this time, but a slower, messier merger, a final embrace that would ultimately consume both structures into a new, unrecognizable form. The brilliant ring we see today may only be the first act in a much longer cosmic drama, a cycle of destruction and rebirth written in the slow, patient motion of two galaxies forever bound by gravity. The original spiral arms of the Cartwheel Galaxy are simply gone, erased from the cosmic record by a single, violent event. Before the Great Collision, this system would have looked much like our own Milky Way, a stately pinwheel of stars and dust with graceful arms winding around a bright center. That familiar structure has been completely obliterated, leaving behind the perfect, almost sterile symmetry of the ring. This total transformation is the real mystery. How can a complex, ordered spiral be so thoroughly and efficiently turned into a bullseye? The answer lies in the precise physics of the impact, a process that computer simulations have only recently been able to recreate. In these digital models, astronomers program in the laws of physics and then fire a virtual intruder galaxy through the heart of a spiral. The results are breathtaking. The instant the smaller galaxy passes through, its gravity acts like a stone dropped into water, but with a crucial difference. The resulting density wave does not merely ripple outward. It violently redistributes the galaxy's angular momentum, which is the inherent spin or rotational energy of all its stars and gas. In the original spiral, this momentum was balanced, holding the arms in their stable, winding patterns. The collision stole that balance. The simulations show the density wave sucking angular momentum from the inner regions and transferring it dramatically to the outer disk. This process acts like a cosmic blender, thoroughly scrambling the original spiral structure. The graceful arms are not just pushed aside, they are stretched, sheared, and torn apart by the overwhelming force of the expanding wave, their stars either flung into the halo or swept up into the new dominant ring. The most puzzling part is the clean slate left behind. The inner disk, the region between the faint inner ring and the galactic core, shows no residual spiral signature whatsoever. It is smooth and featureless. For the collision to have been this effective, the intruder must have struck with a perfect combination of mass, speed, and angle, delivering a shock so specific that it reset the entire galactic disk. The beautiful ring we admire is not just an addition to the galaxy, it is a complete architectural overhaul, a sign that the universe can erase a billion-year-old design and replace it with something entirely new in a cosmic instant. What other galactic masterpieces have been lost to similar acts of celestial violence? The Cartwheel Galaxy is a cosmic chameleon, shifting its appearance completely depending on the light we use to see it. That iconic blue ring of stars is only a single chapter in a much longer story, one that requires the entire electromagnetic spectrum to read. In visible light, we see the final product, the brilliant glow of countless suns. But switch to ultraviolet and the galaxy transforms. The ring burns even brighter, pinpointing the locations of the most massive, hottest, and youngest stellar newborns, stars so ferocious they emit most of their energy in this high-energy, invisible light. This ultraviolet view strips away the older stars and shows us the very engines of the current starburst, the stellar powerhouses driving the galaxy's evolution. Then there is the infrared perspective, which sees not starlight but heat. Here, the ring is a ghostly, luminous wreath of warm dust, a vast shroud of cosmic soot that has been heated by the embedded stars. This dust is the raw material for future planets and solar systems, and its incredible abundance reveals just how much fuel remains for this firestorm of creation. Finally, radio telescopes listen to the cold, dark heart of the galaxy. They map the distribution of neutral hydrogen gas, the primary fuel for star formation. This radio view shows the colossal reservoir of cold gas that was swept up by the density wave, the deep ocean that feeds the fiery storm on its surface. It is in the combination of all these views that the true portrait emerges, a composite image layering the visible, ultraviolet, infrared, and radio data is not just a beautiful picture. It is a functional diagram, a multi-layered map of cause and effect. You can trace the path from the cold hydrogen gas to the warm dust it creates when stars ignite, to the brilliant ultraviolet light of those stars, and finally to the visible glow we perceive from afar. This multi-wavelength approach is the only way to see the Cartwheel Galaxy for what it truly is, a single, dynamic system caught in a continuous loop of transformation, where each type of light reveals a different stage in the life and death of matter itself. This frantic starbirth is a fire that cannot burn forever. The Cartwheel Galaxy's outer ring is currently forging new suns at a rate that defies belief, creating stars dozens of times faster than our entire Milky Way galaxy does across its entire sprawling disk. To put that in human terms, imagine if a single neighborhood in a vast city suddenly started building more houses in 1 year than the rest of the metropolis combined. This is a starburst, a period of frantic, unsustainable stellar creation that is consuming the galaxy's fuel reserves at a breakneck pace. The primary fuel for this cosmic fire is cold hydrogen gas, and the ring holds a finite amount of it. Current estimates suggest that at this furious rate of consumption, the available gas within the ring will be completely exhausted in just a few 100 million years. That may sound like a long time, but for a galaxy, it is the blink of an eye, a fleeting moment in a life that spans billions of years. This stellar nursery is so productive it is essentially on a path to self-destruction, burning through its future in a single, glorious, and ultimately terminal blaze. But the firestorm is not uniform. As we map the ring in exquisite detail, we see that its productivity is patchy. Some segments of the ring are veritable infernos of star formation, while adjacent sections are merely intense. This unevenness is a direct imprint of the initial density wave. The shockwave did not compress the gas with perfect uniformity. It slammed into denser clouds and pockets of turbulence, creating regions of even higher pressure where the collapse into stars became an absolute frenzy. These hyperactive zones are the epicenters of the starburst, where the gas is being converted into stars with maximum efficiency. Other, slightly calmer sections might represent areas where the wave is still piling up material, or where previous supernova explosions have already cleared out some of the fuel, temporarily slowing the process. This variation paints a picture of a system in chaotic, localized turmoil, not a smoothly running engine. What happens when the fuel finally runs out? The brilliant blue ring, the galaxy's defining feature, will not suddenly vanish. Instead, it will begin to fade. The most massive, brilliant stars, the ones that give the ring its blue hue, are also the shortest lived. They will be the first to explode as supernova, their brief lives ending in violent paroxysms. Without a fresh supply of gas to create new generations of stars to replace them, the ring's color will slowly shift from blue to red, as only the longer-lived, smaller and cooler stars remain. The Great Wheel will lose its fiery glow, becoming a ghost of its former self, a monument to a burst of cosmic creativity that burned too brightly to last. The chaos of the Cartwheel extends far beyond its beautiful ring, reaching out to pull another player into its gravitational story. Drifting not far from the fleeing intruder G3 is a second, smaller spiral galaxy, a companion caught in the same cosmic web. This is not a simple two-body drama of victim and perpetrator, but a complex three-body gravitational dance, a celestial waltz with three partners whose steps are written in the language of physics. The presence of this second companion transforms the entire narrative of the collision. It raises the tantalizing possibility that the great impact was not a simple accident, but a carefully orchestrated celestial event. The smaller spiral's gravity, subtle yet persistent over millions of years, could have acted as a cosmic nudging hand, gently perturbing the orbit of G3 and steering it directly into the path of the Cartwheel. Imagine three friends spinning in a vast, dark room, each holding an invisible rope tied to the others. A slight tug from one can send another stumbling into the third. On a galactic scale, that stumble is a collision that reshapes an entire island of stars. This triple interaction is astronomically rare and notoriously difficult to model. Scientists call it the three-body problem, a fundamental puzzle in physics where the gravitational interactions between three massive objects become inherently chaotic and unpredictable. Unlike the stable, elliptical orbits of a two-body system, adding a third mass creates a constantly shifting dance where long-term predictions are nearly impossible. The movements of the Cartwheel, G3, and this second companion are a real-time demonstration of this cosmic chaos, a billion-year-long experiment in orbital instability. The second companion is not merely a historical instigator, it is an active participant in the present. Its gravity continues to pull on the tidal debris streaming from both G3 and the Cartwheel, subtly shaping those long rivers of stars and gas. It may even be influencing the future trajectory of the fleeing intruder, potentially altering the timing or the very possibility of that predicted second encounter. This triple galaxy system forces us to see the cartwheel not as an isolated spectacle, but as the brightest member of a deeply interconnected family, a family whose turbulent relationships are still being written in the silent, patient pull of gravity. This starlight holds a secret code, a series of ghostly fingerprints that betray the true violence churning within the ring. When astronomers pass the galaxy's light through a spectrograph, splitting it into a rainbow of constituent colors, they do not see smooth, unbroken bands. Instead, they find a forest of sharp, brilliant spikes known as emission lines, each one the unique signature of a specific chemical element in a hot, excited state. But in the cartwheel, these lines are not clean and narrow. They are distorted, mangled, and stretched into bizarre shapes that reveal a gas-filled environment in utter turmoil. Some lines are dramatically broadened, smeared out because the gas clouds emitting the light are being whipped around at fantastic speeds, some moving toward us and some away, all at the same time. This is the Doppler effect in action, the same phenomenon that changes the pitch of a passing siren, but applied to light instead of sound. The broader the line, the more violent the motion. Other lines are not just broad, but split into two distinct peaks. This double peak is a telltale sign of two separate, colossal streams of gas moving in opposite directions at thousands of kilometers per second, like witnessing the simultaneous blast wave from an explosion rushing outward while a reverse shockwave collapses back inward. Then there are the skewed lines, asymmetrical slopes that look like a mountain range after an earthquake. These indicate that the gas is not moving uniformly, but is a messy mixture of different components, some accelerating, some decelerating, all superimposed into a single, chaotic signal. Each distorted line is a direct witness statement. The extraordinarily broad lines come from regions near supernova explosions, where gas is being accelerated to a significant fraction of the speed of light by the sheer force of the blast. The double-peaked lines often point to vast, colliding shells of gas or the bipolar outflows from newly formed stellar giants. The skewed lines map the turbulent interfaces where the density wave plows into quiescent gas, creating a maelstrom of different velocities. By decoding this spectral cacophony, we become cosmic diagnosticians. We can take the temperature of the gas, measure its density, and even calculate the immense pressures at work, all from the subtle shifts and shapes in these ethereal lines. The light from the Cartwheel Galaxy is not a serene picture. It is a frantic, overlapping chorus of screams and shouts from a battlefield, each one telling its own piece of the story. An invisible storm of subatomic shrapnel rages within the brilliant ring. These are cosmic rays, not rays of light at all, but a hail of atomic nuclei and protons accelerated to nearly the speed of light. Within the Cartwheel's frantic stellar nurseries and supernova blast zones, nature has built a particle accelerator of unimaginable power. Each massive star that lives fast and dies young in a supernova explosion does more than just scatter heavy elements. It acts like a cosmic bomb detonating in a magnetic field. The blast wave from the explosion, expanding at millions of miles per hour, traps charged particles within its turbulent front, whipping them back and forth across the shockwave. With each crossing, the particles gain a tremendous burst of speed, like a surfer being pushed repeatedly by an endless wave, until they are ejected into space as cosmic rays. The sheer density of supernova in the ring means this process is happening continuously, creating a thick fog of these high-energy particles flooding the entire structure. We cannot see this fog directly, but we can detect its ghostly signature. As these ultra-fast protons and atomic nuclei fly through the galaxy's powerful magnetic field, they are forced to spiral along the invisible lines of force. This violent, spiraling path causes them to emit a specific type of radio wave known as synchrotron radiation. It is this synchrotron emission that gives the entire ring a faint but distinct radio glow, an invisible shroud of energy that maps out the areas of most intense particle acceleration. This process does not stop with radio waves. When these high-speed cosmic ray protons collide with the nuclei of slower-moving hydrogen atoms in the gas clouds, the impact is so violent it can create new particles, including neutral pions that almost instantly decay into pairs of high-energy gamma rays. The Cartwheel Galaxy is therefore not just a source of visible light and infrared heat. It is also a confirmed source of gamma radiation, the highest energy light in the universe. This makes the galaxy a crucial natural laboratory. The cosmic ray fog generated here is a miniature, nearby version of the diffuse background of high-energy particles that permeates the entire cosmos. By studying this concentrated source, we can begin to solve a century-old mystery, understanding how starburst galaxies across the universe have collectively filled the voids of space with this invisible, energetic rain that constantly bombards our own planet. What other universal forces are being forged in the chaos of this celestial ring? This brilliant ring of fire tells its own history in a subtle gradient of color. From its searing inner edge to its slightly softer outer rim, the hue of the starlight shifts, painting a timeline of the galaxy's violent rebirth. The innermost curve of the ring burns with an intense electric blue. This is the signature of stellar youth, the raw glare of the hottest and most massive stars in the universe. These are the giants, behemoths dozens of times larger than our own sun, and they live fast and die young. They ignite with a ferocious blue-white heat, burning through their nuclear fuel in just a few million years before exploding as supernova. Their dominance at the ring's inner edge reveals a profound truth. This is the very forefront of the expanding wave, the place where star formation is happening right now in this very cosmic moment. The gas here was compressed most recently, igniting these brilliant, short-lived titans. As your eye travels outward across the ring, the blue slowly mellows, blending into a slightly redder, more golden tone. This is not the deep red of ancient stars, but a subtle shift indicating a slightly older population. The stars here are still young, but they are a few million years older than their brilliant blue siblings on the inner edge. The most massive blue stars in this zone have already lived out their short lives and vanished in spectacular blasts, leaving behind their longer-lived, smaller and cooler cousins. These stars are less massive, burn at lower temperatures, and therefore glow with a warmer, more golden or reddish light. This color gradient is a direct visual readout of the ring's expansion. Imagine a time lapse of a forest fire sweeping across a landscape. The leading edge of the fire is the hottest and most active, a brilliant blue-white flame. Just behind it, the fire has passed, leaving behind glowing embers that radiate a deeper, redder heat. The Cartwheel's ring is that cosmic fire frozen in a single frame. The inner blue edge is the active flame front, while the outer redder rim is the lingering embers. By simply reading this color-coded map, astronomers can rewind the entire starburst. They can calculate how long it took for the wave to travel from the outer reddish edge to the inner blue edge, revealing the speed and duration of this celestial firestorm. It turns the entire galaxy into a colossal clock, its face painted in the vibrant colors of stellar life and death. What other cosmic histories are written in light, waiting only for us to learn how to see in color? This perfect ring of fire is a temporary masterpiece. The very same gravitational forces that sculpted this celestial bullseye are already conspiring to tear it apart. Computer simulations that rewind the collision can also fast forward, showing us the Cartwheel Galaxy's future, and the prognosis is one of beautiful dissolution. The models reveal that the ring structure is not a permanent new state for the galaxy, but a fleeting, unstable phase in its long evolution. Over the next few 100 million years, the magnificent symmetry will begin to crumble. The ring itself is a delicate balancing act, a structure held in place by the precise interplay between the outward push of the density wave and the inward pull of the galaxy's gravity. But nature abhors a perfect imbalance. tiny gravitational perturbations, the slight tugs from the orbiting companion galaxies, and the intrinsic clumpiness of the ring itself will begin to amplify. These small disturbances act like seeds of chaos, growing exponentially as they ripple through the system. In the digital simulations, we watch as the smooth, continuous ring first develops kinks and knots. These denser regions, the superstar clusters we see today, begin to exert their own powerful gravitational influence, pulling on the surrounding gas and stars. The uniform band of light starts to warp, fragmenting into brilliant arcs and disjointed segments. It is as if the cosmic wheel is developing cracks, its perfect circle breaking down into a series of dazzling, disconnected beads. This fragmentation is the first step toward a profound transformation. The galaxy, having been violently thrown out of its ancient spiral equilibrium, is now seeking a new one. The gravitational potential of the system is trying to settle, to find a stable configuration, and the rigid ring is not it. The simulations show the fragmented arcs beginning to wind, pulled by the differential rotation of the galaxy. Stars and gas on the inner part of the ring orbit faster than those on the outer part, and this difference in speed gradually twists the broken segments. What was once a perfect circle slowly begins to curl, its pieces stretching and merging, slowly reforming into the beginnings of new, chaotic spiral arms. We are not watching a destruction, but a metamorphosis. The galaxy is recycling its own structure, using the material from the temporary ring to build its next form. This celestial rebirth reveals a deeper truth about the cosmos, that even the most stunning and seemingly permanent structures are merely waypoints in an endless dance of change, a single frame in a billion-year-long movie of transformation. A faint, warm breath of ionized gas fills every corner of the Cartwheel Galaxy. This is not the brilliant fire of the ring or the cool dust of the spokes, but a pervasive, glowing fog known as the diffuse ionized gas. It is the galaxy's atmosphere, a superheated plasma where atoms have been stripped of their electrons, causing the entire medium to shine with a specific, ethereal light. This glow is most intense in the ring, as expected, where the furious ultraviolet radiation from newborn massive stars is constantly boiling the surrounding hydrogen. But the truly strange part is that this ionized fog does not stay put. It leaks, seeping out from the stellar nurseries and permeating the vast, quiet spaces between the stars, even reaching into the seemingly empty regions of the inner disk. How does this intense radiation manage to travel so far from its source? The interstellar medium of the Cartwheel is not a solid wall. It is a porous, frothy sea, riddled with tunnels and cavities carved by eons of supernova explosions and stellar winds. These pathways act like a system of cosmic vents, allowing the destructive energy of the starburst to flood into regions that should be shielded and dark. This creates a galaxy-wide environment that is perpetually energized, a place where no pocket of gas is ever truly safe from the searing touch of distant stars. The presence of this diffuse glow points to another, more violent heating mechanism as well. Shockwaves are also rippling through this medium, the leftover energy from countless stellar explosions. These shocks violently compress and heat the gas as they travel, contributing to the widespread ionization. This faint, uniform light is therefore a signature of the galaxy's total energy budget, a measure of how much power is being pumped into its ecosystem from both the steady leak of radiation and the sudden, jarring blasts of kinetic force. It reveals a galactic environment in a state of constant, low-level fever, its very air set aglow by the unrelenting storm of activity at its core. This cosmic bullseye is far more than a solitary spectacle. The Cartwheel Galaxy is a living window in time, a local laboratory for events that shaped the entire cosmos in its youth. Billions of years ago, the universe was a far more violent and crowded place. Galactic collisions and mergers were commonplace, driving the rapid evolution of galaxies and fueling epic bursts of star formation. Most of those ancient ring galaxies are now impossibly faint and distant, their light stretched into near invisibility by the expansion of the universe. Studying them in any detail is a monumental challenge. The cartwheel, by a cosmic stroke of luck, is our nearby analog. It is close enough for our telescopes to dissect, allowing us to observe the intricate physics of a ring galaxy in high definition. Every detail we uncover here, from the propagation of the density wave to the behavior of its magnetic field, gives us a template for interpreting the faint whispers of light we receive from those ancient, faraway systems. We are essentially using this nearby galaxy as a Rosetta Stone, a key to translating the chaotic history of the early universe. By understanding the cartwheel's present, we can peer into the past of countless other galaxies, seeing in its brilliant ring a phase that was once a fundamental part of cosmic evolution. It transforms this beautiful anomaly from a cosmic oddity into a universal archetype, a vital piece in the puzzle of how all galaxies, including our own, were forged in the fires of collision. From its propagating ring of fire to its cannibalized companions and mysterious dark matter halo, the Cartwheel Galaxy is a treasure trove of cosmic weirdness that continues to challenge and inspire astronomers. These 30 strange phenomena do not just paint a picture of a single oddball galaxy. They reveal a dynamic, evolving system where destruction and creation are two sides of the same coin. It is a place where a single violent event can erase a billion-year-old spiral design and replace it with a temporary bullseye, where invisible magnetic hands sculpt chaos into order, and where the birth of a million stars in a single cluster is just part of the daily routine. This galaxy is a testament to the universe's boundless creativity and its relentless transformative power. As we continue to observe this galactic marvel with ever more powerful telescopes, who knows what other secrets it will reveal? The next generation of observatories will peer even deeper into its heart, perhaps finally confirming the infant tidal dwarf galaxies budding from its ring or catching the first moments of a gamma-ray burst. Every new instrument turns a new page in its ongoing story. So let us know in the comments which phenomenon blew your mind the most, and don't forget to subscribe for more journeys to the farthest reaches of our strange universe.